Pole from 2 points. There is a pole of height 2 meters. 2 points A and C are on opposite sides of the pole. Point A is 3 meters away, and the point C is 1 meter away from the base of the pole on the ground. Find sine angle A plus angle C, cos angle A plus angle C, and tan angle A plus angle C. To solve the problem, let us draw a figure with all the details given in the question. Let the line BD represent the pole where B denotes the top of the pole and D is the base. Thus, BD is equal to 2 meters. Also, AD is equal to 3 meters and CD is equal to 1 meter. Applying the Pythagoras theorem, in triangle ABD, we get AB square is equal to AD square plus BD square. Substituting the values, we get Therefore, AB is equal to root 13 meter. To find BC, we need to apply Pythagoras theorem in triangle BCD. BC square equals CD square plus BD square. Substituting the values, we get Therefore, BC is equal to root 5 meter. Now, in triangle ABD and triangle CBD, we can find the sine and cosine ratios for angles A and C, as the hypotenuse in each of the triangles is known. Sine angle A equals opposite side over hypotenuse. Substituting values for sides, we get sine angle A equals 2 over root 13. Similarly, we can calculate the cosine of angle A. Cos angle A equals adjacent side over hypotenuse. Cos angle A is equal to 3 over root 13. In triangle CBD, sine angle C equals opposite side over hypotenuse. Sine angle C equals 2 over root 5. Cos angle C equals adjacent side over hypotenuse. Cos angle C equals 1 over root 5. By applying the compound angle identity for each of the ratios, sine and cosine, we can get the answers to the questions. Let us recall the identities for sine and cos of compound angles. Substituting angle A and angle C for alpha and beta, we get sine angle A plus angle C equals sine angle A cos angle C plus cos angle A sine angle C. Substituting the values of sine A, cos A, sine C and cos C from equations 1 to 4, we get sine angle A plus angle C equals, or sine angle A plus angle C equals 8 over root 65. Therefore, sine angle A plus angle C equals 0,99. Now, substituting values in the identity for cosine of compound angles, we get cos angle A plus angle C equals cos angle A cos angle C minus sine angle A sine angle C. Cos angle A plus angle C equals, or cos angle A plus angle C equals negative 1 over root 65. Therefore, cos angle A plus angle C equals negative 0,12. Now recall the tangent ratio. Now, if we substitute angle A plus angle C in place of x, we get the tangent ratio for the compound angle, angle A plus angle C. Therefore, tan angle A plus angle C equals sine angle A plus angle C over cos angle A plus angle C. Substituting the values of sine angle A plus angle C and cos angle A plus angle C, multiplying the numerator and the denominator by the negative square root of 65, we get tan angle A plus angle C equals negative 8. Thus, we have calculated the values of sine angle A plus angle C, cos angle A plus angle C, and tan angle A plus angle C.
Need more help? Subscribe to our channel Can't wait that long? Ask Masky to help you and let the math finally start mathing.